This is Mohammed Ghous, and this is lecture 3 of my hypothesis, quantum relativity. And this in this lecture, we talk about some mysteries of physics like dark matter, dark energy, black holes, and area of universe. So let's start with the topic area of universe. Now, in my previous lecture 2, I have described the Einstein's field equations as a superpositional term and solution with stress energy having a new constant, a phi constant. Now, why I have written this phi one? Now, according to my transformation, the transformation law of tensors, and the function we used for the mapping of high dimensions with lower dimensions, we have used this term x mu. Let's say this is a lower dimensional term. Its probabilistic mode squared with x alpha. Now, according to this function, when we differentiate it, it comes to here, and at n equals 9, the extra value will becomes 512 at 2 power 9. And as the g mu v has no other constant, that's why we have written 512 here, giving us a new field equation with different magnitudes depending upon the number of dimensions. Now, if we include the dark energy term, it can be written as 512 g mu v plus 512 n g mu v and equals to n t mu v. But what if I said I only talk about the amount of energy and I will take the constant from here to here? What will happen? In this case, we will get a new constant known as the Gauss constant. This constant is called the Gauss constant, written with the space-time curvature amount, and it affects the cosmological constant. It's a new constant describing the dark energy term. Now here this constant has a value at n equals 9. It has a value of 7 pi multiplies by 10 power 767. The same as the value at n equals 9 when we are talking about the stress energy constant. Now this value defines the area of universe in terms of the curvature of space-time. It's simply stating that the most biggest space-time energy level is that value, and this is the limit of the total area of universe, or the most powerful space-time curve. Now, what are its relation with graviton? Now, in other words, we have simply derived graviton. What are the properties of graviton? Graviton has a spin of 2. It is neutral charge. It has a neutral charge, and it is massless. By using these three terms, we have described this thing. This thing here is describing the a graviton here. Let's say, let's make a cube here, and let's say in this cube we are talking about Earth making a curve, bending the space-time fabric. And let's say we have taken the 5% of universe as an average curvature, means many galaxies, galaxy clusters, stars, planets are making curve, and the addition of all the curves made within the 5% of the universe, we have made it simply under a spheric shaped space-time curve, and this here circle is representing the 5% of universe making curve togetherly, and this is describing the area of universe. And if we apply this constant, it will describe that what are its magnitudes in different dimensions. Like in 4 dimension, how it looks like in 5 dimensions, how bigger the gravitons we can imagine. Now this is called a graviton. Means our 5% universe, we consider it is the most smallest graviton. and that's why they are less interacting because we are itself living in a very small graviton, and there may be even more bigger gravitons. Now, this hypothesis is stating that a graviton is basically this thing. Then, what is dark energy? So, before dark energy, let's talk about dark matter. So, dark matter is nothing but basically the interaction of two gravitons with each other. All right, and the answer that how will they interact and what is in between these gravitons, we will cover it in lecture 4. But for now, let's talk about their interaction, that how they interact. I mean, let's say there's a graviton of n equals 2 and there's a graviton of n equals 3. Now, the interaction with each other, like this is our universe, and this is the interaction of a much more bigger graviton, and this is another graviton, let's say in the same energy level, interacting with our gravitons. Now, this interacting point describes dark matter, which bounds the galaxies. But then, what is dark energy? If they are bounding it, these gravitons, in different dimensions, different energy levels, bounding it and increasing the amount of gravity here, then what is dark energy? So, dark energy is nothing but the combining phenomena of two gravitons with each other through a black hole. And that's why when our mass reaches a limit, it becomes a singularity, because it is a singularity. Singularity is nothing but it defines the maximum energy level value. And if the mass in lower dimensions uh, approaches a mass higher than their energy level, this simply combines with a much more bigger graviton. Now this is singularity, and this simply combines with each other to form a much more bigger graviton. Now, how this all process works, I will define it in a way like, let's say this is a graviton at two indices and with three. Now, when they connect with each other in singularities, slowly they will deform and combine with each other with the speed of light. And why it happens with the speed of light, I will discuss it in lecture 4. But for now, let's talk about its interaction. So, slowly they will combine it with each other, and a stage reaches when they form a much bigger and massive gravity. But there is a question here that it has two indices and it has three. After their combination, what is the value of dimension? Now, as I have said early in my lecture 2, the index is 2 and the 3 one is basically contracted. And that's why we simply write it 3 or 2 with our contracted version. Alright? Forming a much bigger graviton. And this thing is happening with us, like this our 5% universe is continuously expanding in all directions, and the reason behind it is that they are interacting with the space-time through black holes, and they're slowly accelerating to form a much bigger graviton with very high spaces. Like, let's say this is an object A and this is object B. It has distance like this, but after its combination, the distance increases. It is simply stating that the graviton is basically a quanta of existence because it consists space and time. It is simply stating that due to the observation of final frame within their consciousness, uh, it has controlled the space amount and the time continuum amount, stating that our destiny is fixed. In a more philosophical way, our destiny is fixed. Means the timeline is fixed. It depends upon how fine frame observes it. Like in my consciousness, let's say I'm thinking in my thoughts a book. Let's say I'm thinking of a book. It forms a bubble-like structure. If I am fine frame, it forms a bubble-like structure, and this bubble is called space-time, in which, in that certain timeline, which I collapsed in my thoughts, making a timeline, let's say, a book, and let's say I'm thinking of another object, maybe some B object, let's say. So this will simply form another bubble-like structure of a space-time, and maybe they will interact with each other depends upon how complex they are. I mean, let's say I am thinking of 60 or 70 object, then the bubble will much more bigger as we are talking about high dimensions. Now let's talk about black holes. In simply, black holes is basically a connection between higher and lower or higher dimensional gravitons, forming a singularity, because singularity is driving the limit between two energy level gravitons, and that's how a wormhole is predicted. That is basically a black hole or a connection between two gravitons of higher dimension and a lower dimension. So in lecture 4 we will talk about how these gravitons will travel in the consciousness of fine frame and what are its dynamics. Thank you.